Okay. So guys, now we are going to discuss another important concept related to security in ASP.NET Core Web API, that is encryption and decryption. So encryption and decryption is basically for protecting the data during the transmission. So particularly whenever we are sending some sensitive information from the client application to the server or from server to the client application, we need to protect the sensitive information so that the middleman or man of the middle attack should be reduced, right? So in that case, so what we need to do, we need to use something called encryption and decryption. So encryption and decryption means what? Now, whatever the original data, that data will not transfer in plain text. That data will convert into some kind of right unreadable format, or you can call that format as ciphertext using some kind of algorithm. And that ciphertext we need to transfer over the network. So whenever the data is received by the server will decrypt the data and process. Similarly, whenever the server trying to send some data to the client, then in that case, the server again needs to encrypt the data, and that encrypted data it will transfer over the network to the client. The client will receive the data in encrypted format. Again, the client will decrypt the data and he will perform the operation. So that is what we need to understand. So encryption means it is a technique which is used to protect the data by converting it from its original readable form, which is also called as a plain text, into an unreadable format, which is called as a ciphertext. This transformation uses a cryptographic algorithm. You can go with symmetric or you can go with a asymmetric algorithm. So what is symmetric, what is asymmetric, we'll discuss along with one encryption key. The purpose is to ensure that if unauthorized people intercept the data during transformation or during storage, they cannot understand or misuse it. So basically, the encryption means it is a way or form for transforming plain text into some unreadable format, which is called ciphertext. And what is decryption? It is just the opposite of encryption, converting the ciphertext into plain text, right? So why we need encryption and decryption? Because of the data security. So no unauthorized user can access the data. Even though they access the data, they cannot understand the data because the data is going to be in ciphertext. Data integrity, all the encryption, guys, remember, the encryption doesn't direct prevent tampering. For example, you are sending some encrypted data. The man of the middle, they got the encrypted data. They can modify the data. That modified data they can transfer to the server. But in that case, what will happen now? Whenever the data, the encrypted data is changed, that data will not be decrypted. So that's what you need to understand. Privacy compliance, right? Many organizations, like for example, if you are developing some banking application involving some financial information, then in that case, we need to follow some industry standard, GDPR, HIPAA, and PCI DSS, right? And they are providing some kind of rules and regulations, or you can say restriction. This is not for all the applications. These regulations are applicable to some medical, some personal details, medical reports, financial applications, right? They are applicable. And they are saying that whatever the data is going to be transmitted over the network, they should be encrypted. Also, they are telling what kind of a algorithm, encryption algorithm to be implemented. That is also possible. And these are the some of the reason why you should use encryption and decryption, right? Now, what are the different types? As we already discussed, so there are two types of encryption and decryption algorithm. One is a symmetric encryption and decryption. One is a asymmetric, right? And most of the time in the industry, we are going to use a symmetric encryption and a decryption. In the case of a symmetric encryption and a decryption, what exactly it uses? It uses the same key for both encryption and decryption. That means, first of all, the server will generate a encryption key. That key will be shared with the server. Sorry, that key will be shared with the client in a secured manner. The client will use the key to encrypt the data. Along the same time, he will use the same key to decrypt the data. And from the server side, it will again use the same key to encrypt as well as the same key to decrypt. And this is very fast, efficient. And using this encryption, I mean symmetric encryption, we can transfer large amount of data, right? And here There are two approaches are used. One is AES, Advanced Encryption Standard. Another one is DS. This is the older one, or you can say the deprecated one. Nowadays, no one is using this algorithm. That is DEC. Most of the applications nowadays they are using this AES encryption and decryption algorithm. So we will use this AEC, Advanced Encryption and Decryption, encrypt the data as well as to decrypt the data. Again, we are going to send a huge amount of data, large amount of data. So we are going to follow this encryption option, symmetric encryption. Another option is asymmetric encryption, decryption. So in this case, what will happen? Now the working principle is going to be same, but in this case, it is going to use two key pair, right? One is public key, another one is private key. Public key is used for encryption. Private key is used for decryption. That public key and private key will be shared between the client and the server. The client will use the public key to encrypt the data. That encrypted data will be transferred to the server. Server will use the private key to decrypt the data. Again, whenever the server needs to send the data, the server will use the public key to encrypt the data. Again, once the data received by the client will use the private key to decrypt the data. And one of the most popular algorithm is RSA, or you can use ECC to implement asymmetric encryption and decryption. So mostly what algorithm we are going to use? We are going to use a symmetric algorithm because we want to transfer large amount of data. Here using this one, you cannot pass more amount of data. The data size is going to be limited, and that is the reason why we need to use this symmetric. And out of symmetric, we will use this AC algorithm. Why? Because this is the standard nowadays. This is the deprecated one, or you can say older one. Clear, guys?
Yes, sir.
Clear or not? Now, so before proceeding, let us try to understand how the AC algorithm is going to work. Now, if you look at this diagram, there are two parties. One is sender and one is receiver. So this receiver can also be the sender. This sender can also be the receiver. So here you can consider this is the client and this is the server, or it can be the server, right? So the point that what you need to remember, transformation is not one way. The sender can send the data, the client receives the data. The client can also send the data, and the sender can receive the data. So that is what you need to remember. So in this case, first of all, what will happen? That server will generate a secret key. That secret key for this particular client is going to be stored in the database. That secret key will be shared with the client. Now, the client having the original plain text. This plain text client cannot transfer over the network to the server because of the security issues. So what he will do, he will fetch the secret key. Using this secret key, using some AC algorithm, using AES algorithm and using this secret key, the client will convert that plain text into some ciphertext. And this ciphertext will be transferred over the network, over the internet, and the server will receive the ciphertext. Once the server receives the ciphertext, then he will check what is the client. Yes, this is the client. For this client, what is the secret key stored in the database? Yes, this is the secret key. Okay, let me paste the secret key. And once the user pastes the secret key, using the same AC algorithm, it will decrypt the data. And once it decrypts the data, he will get the plain text. Guys, remember earlier, the previous example, we have used hashing algorithm, HMAC and HMAC, whatever. And this time, we are using AES algorithm. So AES is used for encryption and decryption. They provide a method to encrypt the data as well as they provide a method to decrypt the data. But the previous example, what we discussed password hashing, there is no options to decrypt. Only generate the computed hash. Based on the computed hash, you cannot generate the original text. But here, that is possible. Clear?
Yes.
Clear? Now let us understand this with some example, right? So basically, what you need to do, we need to create a two application. One is a server application, which is going to expose the endpoint, which is going to store the client information, which is going to generate the shared secret key. The client application, which is going to consume the services provided by the server. In this case, this server application is going to be a ASP.NET Core Web API application, and this client application you can take anyone. The client can be a MVC application, can be an Angular application, can be a React application, can be a desktop application, can be a console application, can be a Android application, can be a iOS application, can be a IoT. So anything you can take into consideration. And for simple, right, for easy to understand, what I'm going to do, I'm going to create a console application. And using that console application, using C# coding, I will show you how you can consume the services with encryption and decryption. Clear? Clear, guys?
Yes.
So let us proceed and develop the application step by step. So first of all, what we need to do, we need to develop the server application, which is going to expose the endpoint, which is also going to store the client information with the shared secret key. Now, so click on the create button. So this should create the client application. So as we are going to store the data in the database, let us first install the required packages. So two packages we need to install: Entity Framework for SQL Server and the migration package. So these two packages we need to install. Okay. So we have installed these two packages. Next, what we need to do, I need to store the client details in the server. I mean, whatever the client ID, whatever the client secret, that what we need to store. Guys, remember, in previous case with HMAC algorithm, we need the password solved. I mean, one byte array, that what we need to use to generate the computed hash. But in this case, right? What we need to do, we need two keys, right? One is key and one is IV. So key and IV, that what we need to use. So without this initialization vector, you can also work, but for the better security, we need to use this IV. Okay? So basically it is a standard that we need to use two keys. In this case, one is key and another one is initialization vector. Key is nothing but the secret encryption key, which is going to be used in AEC. That key length can be your 128 bits to 192 bits, 256 bits. You can divide this by 8 to get the actual number of bytes. So this initialization vector, this is a fixed size random value used alongside the AEC key. So its purpose is to ensure that each encryption operation produces a unique ciphertext, even if the plain text and key are the same. So what exactly it means? It means, right? It means using this key, we are going to encrypt the data. But that data length is going to be fixed. Length is going to be fixed means what? Now the encrypted data, the length is going to be 256 bit or 192 bits or whatever. So the point that what we need to remember, so in this case, whatever amount of data you are going to encrypt or decrypt, that length is going to be same. So for that purpose, we are going to use this IV. So let me first create a client, right? First of all, let me create a folder called models where we'll create all our right classes. So models folder. So inside this models folder, client key IV. So where we are going to store the client information. So guys, remember, this is not user information. This is client information. So the client is valid or not. So in this case, that client might be a Android application, iOS application, web application, desktop application. That is going to be your client. User is different, client is different. So this is my client IP. So ID going to my primary key. This is the client ID, which is going to be unique for each client. And if you want to do, you can apply the unique index here. Otherwise, you can also apply the unique index, right, for this client ID while you are registered, right, while you are registering the DB context class. In the DB context class, within the configuring method, we can also specify that this client ID is going to be, this client ID should have one unique index. So this is my key, secret key, and this is IP, which is going to right, to provide the initialization vector so that it will generate a fixed amount of length. So next, what I'm going to do, I'm going to perform some CRUD operation over the employee entity. So for that purpose, what I'm going to do, I'm going to create one class file, that is employee. So this is the class file, right? So basically what I'm going to do, I'm going to create one API. That API is going to expose the endpoint for performing database CRUD operation on the employee entity. So while performing the CRUD operation, whatever the data, we need to exchange between the client and server, right? For example, you want to create one employee. That employee object needs to be passed as a encrypted string. Similarly, you are returning a list of employee. You are returning a single employee. So that information, what you are returning from the server application to the client, that information is going to be in encrypted form. So for that purpose, I'm creating this employee model. So I will create one database table which is going to store the employee information, and we will perform database CRUD operation on that employee table. And the operation is going to be performed using encrypted and decrypted data. Next, what I need to do, I need to create my application DB context class. Definitely, this context class is going to have two DB set properties. One is for employee, one is for client IP, and some initial data, seed data. See, first of all, you can see I'm applying some unique index. So if you don't want to use this one, then what is the other option? Other option is apply the index attribute here. So you can apply the index attribute. So guys, tell me what is the syntax?
E is unique to true.
Sorry,
E is unique true.
index attribute. So name of for which column? Client ID. Okay. Then second one is name, whatever the name you want to give, unique, whatever the client, okay, sorry, unique client ID, any name you can give. And what is the next is unique, you have to mark this as a true. Okay, so this is one of the option that is available. If you are not using this option, then you can do this one. So you can apply that this key having one index on this column, and that is going to be unique. So both options are there. Whichever option, this option I'm going to use this one. Clear? So here I'm passing some initial dummy data. So client ID 1, this is client ID default client. So client 1, client 2, client 3, and this is going to be the secret key, and this is going to be the initialization vector, right? So now I'm providing this dummy data. How to generate this key and IP, that is also what I'm going to discuss. And here I'm storing some initial employee information, ID, name, and a salary. So this is the two division properties. So how to generate this key and value, that what I will also show you. I will create one console application for generating a unique key and value. Clear, guys, till now?
Yes.
Yes or no?
Yes.
Okay. So now what I need to do, I need to modify the app setting.json file. See what I'm doing here, I'm storing the database connection DB. So AC server app DB. So any name you can give. For example, I'm going to give the database as employees DB, right? And currently, is there any employees DB available? So let me delete this one. So employees DB, and here I have also added one key, enable encryption. So basically what happened, sometimes you need to enable, sometimes you need to disable. For example, some operations is not working, and in that case you need to check whether the data whatever you are taking is correct data or not. So you have to disable the encryption. So basically this flag what we are setting here, this will mark whether encryption is enabled for the system or not. So that what we will change dynamically. That is the reason why I'm storing that key here. Clear?
Yes.
Okay. Next what we need to do, we need to create one key management service. So this service is going to fetch the AC key and IP for a given client ID. It will ensure that encryption uses the correct credential. So basically, based on the client ID, it is going to fetch the IV key and IV from the database, whether the client ID is present or not. If it is present, what is its associated ID and value, that what we need to pass. So how we can do this? So this is my method. So it will take the client ID, and based on the client ID, it will return the client IV and the keys. Clear? So any question related to this method? Yes or no?
No.
Guys, clear?
Yes.
Okay, so basically, by taking the client ID, it is going to retrieve this information. What is the ID, client ID, key and a IV. So this information it is retrieving. Very simple method. Now, what we need to do? We need to use the AC encryption service. So AC encryption service basically going to perform the AC encryption and decryption. It will use the key and IV retrieved from this key management service, perform the AC encryption and decryption. Encryption will convert the logic, encryption having the logic to convert the plain text into ciphertext. Decryption is going to convert the ciphertext back to the plain text, right? So what I'm going to do, I'm going to create a class file. This class file is going to have two methods. One is for encryption, another one is for decryption. Let us proceed and understand the logic. Why I'm getting this error? I'm getting this error.
That U is capital.
Okay, so there is some typing error. So let us try to understand the code. Okay, so this is my class. This class taking one dependency object, that is the key management service. So this key management service will register into the program.cs class file so that the framework can inject the instance, right? Once the instance is injected, that is what we are storing here. So this encrypt string async method is there, which will take the client ID as well as the plain text. So this is going to be plain text. So it will take the client ID as well as the plain text, right? So in this case, what will happen? First of all, whatever the client ID this method is taking, so we need to validate and check whether this client ID exists or not in the database. If the client ID exists, then this client is not going to be null. If it null, it is invalid client. So once you got the client ID, then this client ID, what we are storing, that is going to be in the form of right, what I can say, encrypted, right? So if you look at this one, so this is going to be stored in this format. So we need to convert that into base 64 encoded string. So this base 64 encoded string byte array, right? We are going to convert again. We are converting that into byte array. So it is storing in the form of a base 64 encoded string, and that base 64 encoded string we are converting back to byte array. So byte array, once we convert, then what we need to do, we have the data. What data we have? We have the plain text, we have the key, which is going to be in byte array. We have the IV initialization vector, which is also going to be in the form of a byte array. Once we have these three things, then what we need to do, we need to use the AES algorithm. So AES algorithm, this create method is going to create an instance. Once the instance is created, we need to set the key and IV. So key is going to be this one, which we retrieved from the database based on the provided client, and same in the case of IV. So once this is done, then what I need to do, I need to create an instance of right this encryptor. So how to create an instance? Call this create encryptor instance. So by passing the key and IP, that encryptor instance is being created. Then what we need to, once the encryptor instance is created, then whatever the plain text, that plain text we also need to convert into byte array. So we are converting that plain text into byte array. So once the plain text is converted into byte array, then using this encryptor, what we need to do? We need to transfer this plain byte array into encrypted byte. So how we can do this? By calling this a transfer final block method. We need to pass the plain byte array. We need to start converting from the part index position 0 till the length, means whatever the number of elements are there. We'll start from the part till the last completely byte array will be converted into encrypted byte, and that encrypted byte will again convert into base 64 format. So this base 64 format is nothing but it is going to be in encrypted format. That encrypted data, what we need to do, we need to return to the client. Similarly, the decrypted method is going to be the same thing. So here we are taking the client ID and the plain text. In this case, we are going to take the client ID and a ciphertext, right? So what I'm going to do, please observe. So using this client ID, first of all, I need to fetch the client information. If the client is not valid, we need to throw this one. If client is valid, then we need to convert that key and value into byte array. So whatever the ciphertext you are passing, that ciphertext we need to convert into byte array. And once we have the key IP and the ciphertext, then what we need to do? I need to create the AC algorithm. And in previous case, we are creating the encryptor. And then here we need to create the decryptor. Create a decryptor by passing the same key and the IP. Encryptor, why we are in this case we are creating encryptor? Because we need to encrypt the data. And why decryptor? Because we want to decrypt the data. So once we have the decryptor instance, then what we need to do? We need to convert, right? Decryptor dot transfer final block. We are having this ciphertext. So please transfer the data from the first till the last position. That decrypted byte we will get, and then we will convert that decrypted byte into string format. So this will return me the data in plain text. So this method is going to convert or encrypt the data, and this method is going to decrypt the data. Clear? Clear?
Yeah. Yes.
Now what will happen? Now we need to use one middleware component, right? So basically, what we need to do. So in our application, right, before executing the action method, right? So before executing the action method, so what we need to do, we need to write one middleware component. That middleware component will take the responsibility to check, right? What it will check? It will check the incoming request. It will also verify the outgoing response. If the incoming request is a post method type or it is a put method type, I mean what? It means if the incoming request having the request body, and if the request body is there, and then what exactly this middleware is going to do? It will inspect the request body, it will get the encrypted text, then it will use, right, again at the same time, it will get the client ID from the request header, then it will call this HC rated decryption string async method by passing the client ID and whatever the encrypted body. Similarly, while it is returning the response, right, then it will check what is the response data based on the right client ID. Whatever the response data you are going to send, if it has, then it will convert that response data to write encrypted text by using this method. That means that middleware component is going to handle both encryption and decryption, because in that case we should not keep focus, right? If you see this encryption and decryption, you can also manage within the action method. So this encryption and decryption you can manage within the action method. Then in that case, what you need to do, you need to write the same repetitive logic multiple times. Again, in action method 1, same encryption, decryption, action method 2, same encryption and decryption. So why should we do all these things? So we can put all these things within a middleware component. That middleware component will handle all these things. Now, our action method is free from this kind of things, and we can focus on the logic only within our action method. Encryption and decryption will be handled by a middleware component. So next, what I'm going to do, I'm going to create a middleware component for the encryption and the decryption. Clear? Clear or not? Yes or no, guys?
Yes.
Yes, sir.
Okay, so we have done this encryption service. Let me keep this one and paste it here. Okay, so let me go ahead and create this middleware component. You know already how to create the middleware component, so I'm not going to discuss many things. So what is the use of this request delegate? Can anybody tell me what is the use of this next delegate? It will invoke the next middleware component which is registered into the request processing pipeline. So why we need this I configuration? Can anybody tell me why we are injecting this I configuration instance here? Guys, tell me.
To get configuration from application JSON.
Sorry.
To get
So
the configuration from everything JSON.
yeah, that is fine. But what is the use here?
I think we can enable the encryption decryption from the config, right?
Exactly. So basically, we need to check whether this encryption enable encryption having a value true. If this value is true, then only we need to encrypt and decrypt the data. Otherwise, there is no use of encryption and decryption. That value we need to fetch. That for that purpose, we are using this configuration instance. Clear? Clear or not?
Yes, sir.
Yes.
Right now. Now what we need to do? First of all, we need to read this enable encryption key from the settings. So that value we are reading, by default it is going to be false. If it has a value, that value it is going to store here. If it is not true, means if it return false, then we are using this not operator will make this condition true. True means it will skip the next middleware component. There is no encryption. Directly call the next middleware component, and once the middleware component execute, return. If encryption is enabled, then we need to do this thing. First of all, we need to retrieve the header, right? The client ID header. Why I'm going to retrieve this client ID header? Can anybody tell me? So without client ID,
Client ID.
yes, without client ID, is it possible to do the encryption and the decryption? No, because without client ID, how we can get the key and the value? Yes, if you are providing some kind of a default client ID, for example, if the client ID is not present, then please use it as a default client ID. That option, if you are providing, that is fine. Otherwise, if you don't provide, then you can also remove this one. Means if there is no default client ID, then you can also use this one. For example, in this case, we are using this one. So that is the reason why I'm using this one. So now, once you have the client ID, then you can request for the encryption service. So once you got the encryption service instance, then you can check what is the request method. If it is method post or if it is the method put, then only we can do the encryption and the decryption. So we are enabling the buffering, right, to allow multiple read of the request body. So what do you mean by this one? See, in this case, what will happen? Now we are accessing the request body. So whatever the data is passed in the request body, that what we are retrieving. Again, model binding case, that again model binder is going to check the same request body. So as we are going to read the data from the request body multiple times, so we need to enable this buffering. So context dot request dot enable buffering will allow multiple read of the request body. Clear? See, this is executing as part of a middleware. Again, once the MVC pipeline start, that model binding which happening, Model binding means again it will read the model binder will read the request body and it will transfer that request body to your action method parameter. That time also again we are going to read, and by default only one time you can read the request body. But as in our scenario, we are going to read the request body multiple times. So we need to use this one. Clear or not?
Yes.
Right. So then we need to create the reader instance to read the data, and we need to read the data. Right. Once you have the reader instance, you can read the request body, which is going to be encrypted format. Reset the position to 0, right? Why you are going to reset? Because later on, again, when someone going to read the data, they will also read from the position 0, means from the right first from the first position. If the encrypted body is not empty, so this is my encrypted body. Sometimes it might be possible that you are calling one post method. That method you are not passing any data. So in that case, this encrypted body is going to be null. So if the body is going to be null, then what we need to do? We do not need to do anything special. So proceed. So if the body is not null, then what we need to do? We need to write a decrypt the request body. So how you can do this? Now, by calling this decrypt string async method, so this decrypt string async method by passing the client ID and the encrypted body. So we will get the decrypted body. So once we got the decrypted body, so that decrypted body byte array we will get, and that byte array we will store in the request body again. So here we are setting this position to 0, means from the 0th position, again that decrypted response is going to be sent. So while executing this logic, if any error occur, then we need to set the status code as 400. Write any JSON response or plain response, whatever you want to return, that what you can return. And executing this return statement means it will terminate the middleware execution. Yeah, right. So once if these things is happening and if there is no exception, then again it will come to here. So store the original response body, right, stream to restore it later. So basically, whatever the original response, if you remember, before few sessions, I have explained whatever the response body, that what you can only return. Like within that method, you can reshape, you can create some kind of copy, that is fine. But that original response body is always going to be returned to the client. So again, what I'm doing here, I'm creating the response right memory stream object, and this response body, whatever we created, that what we are in, right, for time being we are setting in the response body. We are calling the next middleware component. So reset the response body stream position to beginning for reading. So again, that response we are going to read from the beginning. So once we read the response, we will get the response text, and here we need to check if the response text I mean the response is not null or empty, and if the status code is between 200 and 300, that means what? Response is successful and response body contains some data. Then only what we need to do, we need to encrypt the response. For encrypting the response, so that plain text you need to pass along with the client ID. Once you got the encrypted response, you need to convert that into byte array. Set the content length as the length of this byte array, and set the response body length to 0. Set length 0 means we need to start from the beginning, and then we need to write the encrypted response. If any exception occurred, right, then we need to set internal server error, whatever the error message you want to return. Finally, this is my finally block. Within the finally block, what we need to do, we need to read the temporary response body from the 0th position. Then we need to write that response, right, whatever original response we created, that what we need to set here in the response body. And finally, whatever the body we stored here, that what we need to set. So this will, right, what exactly it is going to do, it is going to store the encrypted response. So next what we need to do, we need to create the, guys remember, you might be getting some difficulty understanding this code, I can understand. That is the reason why I have provided statement by statement inline comment. So once you go through the documents, you will also understand, right, what exactly each statement is doing, right. So next what I'm going to do, I'm going to create my employee controller. Within the controllers folder, so this is going to my employee controller. So this employee controller going to expose some kind of endpoints. So basically the typical CRUD operation endpoint, very simple method you can see. So taking the application DB context instance, using the context object, we are retrieving all the employees. Using the context object, we are retrieving a employee based on the ID method. So this is going to create a new employee. This is going to update the employee, right? And this is going to delete the employee. So this logic I'm not discussing. Why I'm not discussing? Because we have discussed this thing many times, right? How to perform the typical database CRUD operation using the DB context. Next, what we need to do, we need to modify the program class. Let us understand what are the changes we need to do. First of all, register the add controller services, disable the right camel cache naming convention. Second one is register the DB context class to use SQL Server connection, right? Next one is we need to register the services. So we have created two services. One is key management service. Another one is AC encryption service. So these two services we also need to register. So apart from this, what we need to do? We need to register the middleware component. So one middleware component we have created. Before the authorization middleware component, we need to register this one, right? So this is going to be my encryption middleware component. So these are the changes what we have done. Next, we need to generate the migration file. So before that, let me test whether this application working as expected or not. I mean, build successful or not. Yes, build successful. Go to the package manager console, right? Add migration. Any name you can give. Then once you generate the migration file, then you need to update the database. Update the database means sync the database with your model. So for that purpose, what command you need to write? You need to write update the database. So this will generate the database. So now if you verify, so this is going to be my database. So employees DB. So you should have two tables. One is a client ID where we are storing the client ID secret and the initializing vector. And another one is the employee information. Now what I'm going to do, right? I'm going to show you, right? Here you can see this is not this is okay. So here I'm storing some kind of a key and value. How this key and a IP are going to be generated. So for that purpose, I'm using one console application. So let me show you that console application also. So how to generate. So let me go ahead, create a console application, .NET console application. See, this is going to my console application. So here I'm using the AC algorithm. Key size I'm specifying 256. You can specify right 512, 192, whatever. So generate a key and generate a IP. So using this AC algorithm, generate a key and generate IP. So that key I'm converting into base 64 string. I'm converting IP also into base 64 string, and then what I'm printing here. So if you run the application, then it will show you the unique IP and a key. So this is my key and this is going to my IP. So this is how you can generate right unique key and IP for each client. Client ID you can give any name, whatever the client ID, but this unique right key and IP you have to generate using this console application. Clear? Clear or not? Guys, is that clear?
Yes, sir.
Okay. Now, if you run the application, then you will see, right, the data, whatever you are going to receive, that is going, you will be received in the form of a encrypted text. See, I'm getting the data in encrypted format or not? Yes or no?
Yes.
Right. Now, what I'm going to do is, I'm going to create a console application as the client application, and I will show you how that client application going to consume the services of our web API application using encryption and decryption. So for this purpose, what I'm going to do, I'm going to create a console application. So let me close this one. I will share this detailed code, right, so that you can practice by yourself. So create a console application. This application name is going to be AC Client App. So click on the create button. Okay, so first of all, what I'm doing, I'm creating one employee.cs class file to deal with the employee data. Let's assume this is the data what I'm going to return. So for similar to this employee class, what I'm doing here in my console application, I'm creating a class file. So similar to your employee model. So this is going to my client application. Right. Then I need to create one service class which is going to perform the AC encryption and decryption. The same algorithm. Guys, remember this AC algorithm, that HMAC algorithm, they are not specific to C# or .NET. They are standard. All the programming languages, they support that AC algorithm. They support the HMAC algorithm. So you have to use the standard algorithms, right? Which is going to be supported by all the framework, all the programming language, all the technologies nowadays, which is mostly used in the industry. So this is my services. The same thing, right? What you can see, that is the key and IP. That what we will share. The server will share the key and IP with the client. The client will store this key and IP in the secured place. And this is a AC encryption service. So taking the key and the IP. So whatever the key and IP, that is going to be in string format we are taking. And then we are converting that string format into what I can say, uh, base 64 encoded string. I mean converting that into your byte array. So I'm declaring two variables to store the key and IP. The constructor will take the base 64, I mean the key and the value in the string format, and these two string format will convert into byte array. That means once you create an instance, you have to pass these two things, and your key and IP is ready. Now this is my encrypted string, so plain text. So if this text is null, we should throw an exception, and you know how to encrypt the data. So the same AC algorithm you have to use, set the key and IP, create the encryptor instance, convert that plain text into byte array, and then transform that plain text into encrypted byte, and that encrypted byte converted into base 64 string. Similarly, the same thing in the case of a decrypt string, ciphertext, yes, creating an instance, using the decryptor instance, converting that ciphertext into plain text, and I mean ciphertext byte array, and then that ciphertext into plain, or you can say decrypted byte array, and then that decrypted byte array will be converted into string format. So this is the method that what we need to use. Guys, remember the same logic, same algorithm, what is used in the server side, the same logic and same algorithm you have to use in the client side. And most of the client application you take into consideration like React, Angular, Android, iOS, MVC, anything, right? You take into consideration, they are providing the support. Similarly, here we are using the AC package, right? Here you can see this AC. This is a package which is provided to us using system.crypto, security.cryptography. Similarly, those framework or those technologies, right? They are also providing some set of packages for this kind of a functionality. So you should not be worried how the client application is going to create this thing. They are having the packages, and they know that I cannot explain right how it is going to work in Android, how it is going to work in iOS. You can talk to Android and iOS people. You can tell them, yes, we are using AC algorithm. This is our key and this is our IP. Please use this key and IP, generate the encrypted text and decrypted text. That's it. So they will take the responsibility how to do it, right? So this is going to be my service. Next, what I need to do, I need to modify the program class to consume the services, right? So let me proceed and show you this thing. So go to the program.cs class file. So first of all, we need to set this thing, right? So this is my key. So which key I'm using here? Key is going to be client ID, the corresponding base 64 string, and the base IP. That what you will get from the server. That what you have storing here. So base URL where your application is running, that is 7140. That what we need to set here, right? So this is my HTTP client instance I have created by passing the base address. That base address is nothing but this one. right? API base URL. So this is going to my base address. Then I'm setting the client ID in the request header. And this client ID is mandatory because based on the client ID, the server will decide what key and IP to be used to encrypt and decrypt the data. Then what I need to do, I need to create the encryption service instance. To create the encryption service, we are already storing this base 64 string key and IP. That what we need to pass. Then what I'm doing here, I'm calling this get all read get all employees async method by passing the HTTP client, which already have the base address, which is already set the right client ID header. And then once you call this method, it is going to display the data. What this method is going to do, let us try to observe. So this method is basically right going to append this API/employees with the base URL, and then it is going to read the response, right? And once it read the response, that is going to be in an encrypted format. And this response thus ensure success code means will ensure if this request, right, whatever the get request you are invoking here, if that is completed successfully, then this statement will execute. Otherwise, from here it will return or it will throw an exception. So if this ensure success status code means this request is completed successfully, then read the response string, and definitely the response is going to be in encrypted format. So we need to decrypt the response using this decrypt strings method. So this response here is going to be JSON. So we need to deserialize that response into list of employees. Similarly, this is my create employee method. So this is my HTTP client, and here this is encryption service, and this is my employee object. So this employee data currently it is in .NET object. So first of all, we need to convert that into JSON. And once you convert into JSON, we need to encrypt that JSON into encrypted JSON. So then that encrypted JSON, we need to set that the data in this case is going to be application/JSON. And then we need to call this API/employees by using the post method. So this post async means it will invoke the post version of the API employee. So API employees in this case get method means it will invoke the get version. And then I'm again doing the same thing. Whatever the data written by the server, that is definitely going to be encrypted format. We'll convert that encrypted data into decrypted response. Then this will return a JSON. That JSON we need to deserialize into our .NET. Similarly, get employee by ID. So API/employee ID. So in this case, it is going to return a single employee object. So we are doing the same thing here. So similarly, update employee, the same. The concept is going to be same. Whatever the employee data we need to convert into JSON, that JSON will be encrypted JSON. Then we are going to call the put async method. So you have to remember HTTP client provides some method get async, put async, post async, and a delete async for performing the right database CRUD operations, right? So for delete, you can call this one. So in this case, we are not sending any data in the request body, and we are not expecting any response. So this is the method which is going to display the list of employees. If employee is null or count is 0, this message is going to be displayed. Otherwise, the list of employees are going to be displayed. Clear? Clear or not? Guys?
Yes, sir.
So let us proceed and see whether it is working fine or not. So let us put right. Let's first run the application and see. So this is my employee data. Yes. Creating employee. Yes. Fetching employee ID. Yes. Updating employee. Yes. Fetching updated employee. Yes. Deleting employee, and after deleting, this is the data. Clear, guys?
Yes, sir.
Right, so this is how encryption and decryption is going to be work. So whatever the data we are sending in encrypted format. And whatever the data we are receiving from the server, again, it is going to be in encrypted format. So we have to decrypt it before using, and before sending, we need to encrypt it. And the same in the case of, right, what I can say, this server hub. Clear? So this is how encryption and decryption works in ASP.NET Core.